Python machine learning, and for this video we'll be discussing about multiple regression. Again, the source for my slides is actually W3 schools. Multiple regression. Multiple regression is like linear regression, but with more than one independent value, meaning that we try to predict a value based on two or more variables. Take a look at the data set below. It contains some information about cars. So let's say, for example, we have here the name of the car, the model, then the volume, and the weight, and CO2 emissions. It's a CO2 emission. So we can predict the CO2 emission of a car based on the size of the engine. But with multiple regression, we can throw in more variables like the weight of the car to make the prediction more accurate. So how does it work? In Python, we have modules that will do the work for us. Start by importing the pandas module. So we import pandas. And the pandas module allows us to read CSV files. So we have done this previously in our previous videos, and return a data frame object. The file is meant for testing purposes only, so you can download it here. So I'll be creating a link for this. So data.csv. So df equals pandas.read CSV and then the file name. That is how we read a CSV file and create a data frame for that. Then make a list of the independent values and call this variable x. So that is x is equal to df. So that's this one. Close in square bracket, and then these are the variables. So we have weight and volume. And then put the dependent values in the variable called y. So df CO2. Now independent variables are the cause, and this is the effect, or this is the more or less what we're trying to predict. Okay, so again, independent variables are the cause, and the dependent variable or values are the effect. So it is common to name the list of independent values with the uppercase x, and the list of dependent values with the lowercase y. This is because maybe to indicate that this one is a list or a compound. So we have several independent values inside this list here. Now, how does it work? We will use some methods from sklearn module, so we will have to import that module as well. So from sklearn, import linear model. From sklearn module, we will use the linear regression method to create a linear regression object. So we'll be creating this object. And this object has a method called fit that takes the independent and dependent values as parameters and fills the regression object with data. So it will fill that with data that describes the relationship. So here we have regression equals linear model dot linear regression. So we have created the object here, and then we now place data on that object basing on the values of x and y. So using the fit. So this will now place data on this object. And with that, so we can have a regression object, we are now ready to predict the CO2 value based on the car's weight and volume. So predicted CO2 is equal to, so the same object that predict. So open close, we have the square bracket, and these are the values. So let's say, for example, the weight of the car is 2,300 kilograms. And the volume is 1,300 cubic centimeters. Okay, cubic centimeters. So this is how we predict. And then the value will be placed in this variable. So let's take a look again. So we have to import linear model. Then base linear model actually have the linear regression method. So this creates an object. So the regression object. And then you have to place data on the regression object using the fit method by supplying the values of x and y. And the regression object now will contain the data that describes the relationship of these two variables. Now, having the data, we can now predict. using the predict method by specifying the two values of the dependent variables or independent variables. So these are the weight and the volume. Then we can now predict. So if we place that in one program, so we import pandas. Then we have from scalar import linear model. So first we read the data file, and then we created a list of x using weight and volume. So and then CO2 for y, and then regression equals linear model that linear regression. So we have created this object, and it has no data yet. So to place data, we just regression that fit. Then we have x and y. So this will now fit place data into this basing from this value. So the relationship of these two values. And now we can predict the CO2 emission. So by providing the value, let's say for 2,300 kilograms and 1,300 cm. So predicted CO2 is 107.2008 something. So we have predicted that a car with 1.3 liter engine and a weight of 2,300 kilograms will release approximately 107 grams of CO2 or carbon dioxide for every kilometer it drives. Coefficient. The coefficient is a factor that describes the relationship with an unknown variable. Example, if x is a variable, then 2x is x 2 times. X is the unknown variable and the 2 is the coefficient. So here, 2 is the coefficient. In this case, we can ask for the coefficient value of weight against carbon dioxide and for volume against carbon dioxide. The answer or the answers we get tells us what would happen if we increase or decrease one of the independent values. So let's say print the coefficient values of the regression object. So import pandas from scalar import linear model. So we read the file, then we have a data frame here, and then create this list using these two values, and then here we have another list. Then regression, so fit. So the same with the previous one, but this time around we don't predict, we just display the coefficient. So the coefficient now is 0.0075595 and 0.00780526. So this one is for the weight and this one is for the volume. Now, so the result explained, the result array represents the coefficient values of weight and volume. So for weight and volume, I had mentioned this a while ago. So these values tell us that if the weight increased by 1 kilograms, the CO2 emission increases by 0.0075595 grams. And if the engine size volume increases by 1 cubic meter, the CO2 emission increases by 0.007800526 grams. I think that's a fair guess, but let's test it. So we have already predicted that if a car with 1,300 cubic meters engine weighs 2,300 kilograms, the CO2 emission will be approximately 170 grams. What if we increase the weight with 100 grams? So the weight we increase with 1,000 kilograms rather. So 1,000 kilograms. So copy the value. So the same. We read the CSV file. Create the list for X based on the data frame, and for Y in the regression. But this time, if we predict, so instead of 1,300 instead of 2,300 for the weight, we increase by 1,000 kilograms, so it becomes 3,300. Then we predict the value. It is now 114. Okay, Now, we have predicted the car with 1.3 liter engine and weight 3,300 kilograms will release approximately 115 grams of CO2 for every kilometer it drives, which shows that the coefficient of 0.00755,095 is correct. So let's compute this one plus 1,000, so increase the weight by 1,000 times the coefficient, so equals 114.75968. So it is the result of this computation. Okay, so that ends this video. So thank you very much for viewing.